Hey, take a seat. Take a seat. Take a seat. Take a seat. Things should not be flying around this room. Okay. I really don't know how anything else flew across the room. That makes no sense to me. Those don't work well. So, quick show of hands again if you do not have a compass. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Quick show of hands if in your group you have more than 2 compasses. Apparently I'm going to have to buy some more. If you have more than 2, I need one of them. Can I get one? Let's grab one of these. No one else has more than 2 compasses in their group. Thank you. Anybody else have more than 2 compasses? You still got one more right there. Thank you. Okay. You'll have, how many, who else has one? Okay, you all have one? Alright. So 2 here. You'll have 1 back here. There's 1 more. Quick show of hands if you do not have 2 compasses in your group at this point. Y'all don't have any? Oh, yeah. So there's that 1. Alright. How many? Y'all only have 1 compass? Okay, we'll just have to make do with 1 there. I thought I had enough compasses, but I will procure some more compasses from somebody around the school. I don't know why I thought I had more than that. But we'll make it work. You will need it for parts of today, not the whole thing. But we'll get into that when we get to the lesson. Right now, let's talk about this. Let's start with what is mathematics. The number 1 answer is what?
The study of patterns and relationships.
The number 1 response is the study of patterns and relationships. Honestly, it hurts me a little bit that we have people who didn't know that that was the answer I was looking for. Okay, listen. Is it? Is it?
No.
What is 2 plus 2?
4.
It's what?
It's a math.
It's an equation.
It's no.
It's a math term.
It's not. Be careful. It's not an equation. It's an expression.
I'm not saying I'm the one that did that.
You just said you were.
Stop and listen. Instead of trying to like pawn off on someone else or do whatever else, learn from your mistakes. Please understand. Like, yes, some of these things may be true, right? But at the end of the day, is math only adding, subtracting, multiplying, and dividing?
No.
No, you studied exponents, right?
Yeah.
You studied, even in this class, we've started studying squares. You studied a lot of things in math other than just 2 plus 2 and adding, subtracting, things like that. And what everything that you have studied in math has in common is that we are looking at a study of patterns and relationships. That's what math is at its core. And hopefully you start to take that idea on, and it's not just, hey, that's what Mr. Kinney says it is, but it is the study of patterns and relationships. And that's why I had the second question in there of what is a conjecture, right? Okay? Does anybody know who went to the textbook and actually got an answer out of the textbook?
I did. No, you didn't.
Which of these up here probably did that?
The one under the one that says, no,
So I'm going to stop.
that one.
That one?
No, yeah.
This one has 1 extra word, but a conjecture is a mathematical statement that appears to be true but has not been formally proved yet. Okay? The reason why I bring that up is when you are looking at patterns and relationships or trying to find patterns and relationships, you should be making conjectures. You should be making predictions about what you think is true. Math at its core is that study of patterns and relationships. Ezra, please get your stuff. Jaden, when I'm at the front of the room, I need you to pay attention and be a part of the conversation. Okay? So, it is the study of patterns and relationships. Put the expo cap on and stop writing right now. Pay attention. So it is the study of patterns and relationships, and so we're going to find patterns that we want to believe are true, and so we're going to make conjectures about them. But then we need to formally prove them, meaning we need what to prove our conjectures?
Evidence.
Evidence.
Ooh.
We need evidence. You're going to make claims with a conjecture. And then with those claims, with those conjectures, we need to collect evidence to hopefully prove them. And so let's start getting into the rest of the actual part of the lesson, but I just want to emphasize those details. So here's our agenda. We're going to look at I apparently forgot to update this from yesterday. We're actually done with these three. That's where we're going to pick back up, is recapping this. And we're going to get into activity 1.3, and then we're going to get into lesson 2, which is where we start to learn how to create a true square. You remember how this getting started was trying to sketch a square and get close? We're going to actually learn how to create a square in the next lesson. All right. So we looked here. We're trying to differentiate informal and formal geometric reasoning, and we're calling key features of geometric figures. And one of the things we did here, what conjecture did we make from activity 1.1? We drew these line segments in. And what conjecture did we make? That's not what we drew in. What am I doing with my life? We drew in these. And what conjecture did we make about A, B, and C? They don't equal 90. You're missing an important word. Something about them equals 90. They what? They add up to 90 degrees, right? So we said, because we even looked at it, we looked at those three squares, and we added the angles up, and we got close to 90 degrees. And then we got to here, and remember these squares were what? They were bigger. And when these squares were bigger, we checked, and what did we use, by the way, to measure the angles?
Protractors.
The protractors, right? So we learned how to use those protractors yesterday to measure angles. And so we looked at A, B, and C, and even when the squares were bigger, the measure of angle A plus the measure of angle B plus the measure of angle C was still what? It was still 90 degrees. And so we had a conjecture, we made a claim that we think the sum of those three angles was what? The sum of those three angles will always be 90. But then we actually proved it. How did we prove that the sum of those three angles will always be 90?
We line the angles up together and 90 degree angles.
So we used what kind of paper with that?
Patty.
Remember how we copied those angles onto the patty paper, and we lined the patty paper up. Does anyone have their patty paper with them? Can I see it real quick? Here we go. Right? So I made it a little bit darker on mine, but remember we lined the patty paper up, and then we measured the sum of those three angles, and it's hard to tell from it out back, but if you look at these three angles, it's making a 90-degree angle, right? And so if you weren't here yesterday, remember the video's already on YouTube, but we lined up those three pieces of paper to show, oh yeah, the sum of those three angles is in fact 90. And so we're going to use patty paper some today as well. But before we do that, we're going to look here at activity 1.3. I want you to hear me very clearly on this. Go to activity 1.3 if you haven't already. But there is not a right or wrong answer here. I want you to practice making conjectures. One of the things that we oftentimes do, right, we talked about arguments yesterday. What is an argument?
Make a claim.
You need to make a claim
And provide
and provide evidence. We need practice doing this. We need to make a claim and provide evidence. And one of the things we're going to do is we're going to draw auxiliary lines. Were these dashed lines originally there? No. That's something that was added in to try to help us find some extra pieces of information. Drawing extra lines like this will help us, and we can actually make other auxiliary lines I'll show you in a little bit. But I do want to point this out because this is going to matter for this lesson and future lessons. It talks about rigid motions like translations, reflections, and rotations. And so hopefully you talked about translations, rotations, and reflections last year. Does anyone know? No?
I remember we did.
You definitely should have talked about this in your 7th and 8th grade math classes. Does anyone know the name for all three of those things together? Shane? Well, remember, rotations is just one of those three. Translations is just one of those three. But all of those are going to change the shape in some way. So they are called transformations. Transformations are something you're going to study in Algebra 1 and in Algebra 2, and if you may take it, pre-calculus. Transformations is something, a pattern in a relationship that shows up throughout all of mathematics. And so you need to be aware, we're going to talk about these transformations, these rigid motions, quite a bit. So notice what they did right here. You see the original three squares that we had? See them? What did they do to those original three squares? What does it say? Read the statement. Let's consider a new diagram that is... So, we translated these squares up. What's another word to show how these squares got up to here? They were not rotated. They were translated. They weren't. They could have been reflected. That's not really what happened. We'll talk about the difference later. But there's another word that teachers often use called a shift. Do we remember that term at all? Tomorrow, maybe? No? Okay. But think about it this way. If I take this, I'm translating it up as a mathematical term, but it's also shifting it up. Okay? So there's oftentimes called shifts, but the proper mathematical term is translation there. So, we have this new diagram. We've shifted these three squares up, creating a new thing. We've added in these auxiliary lines here. And all that this is asking you to do is look at what other angle measures or side lengths can you determine using these added figures. So, we already know that angle A is what angle measure?
45.
45 degrees. We already know that angle B from yesterday was what? 27, I think. It was either 27 or 26, one of those two. But if you went with 27, angle C had to be 18. If it was 26 here, it was 19 here. Because remember, the sum needed to be what? 90. So what we want to consider at this point is, what other angle measures or side lengths can you determine in this figure? Now, I don't think they ever gave you a length for any of these sides, did you? Did they? Let's do this. Let's say that EF is 1. Let's just call it 1. Come up with, as a group, some conjectures, some things that you may believe to be true. And don't stop. I'm going to give you all 10 minutes to come up with as many conjectures as possible, and we'll have a whole class discussion about it to see what might be true and what might not be afterwards. There's no right or wrong. The only thing that will be an issue is if you do nothing. So no heads down. Let's get to actively collaborating, talking with each other. What are your questions? Yes, Emily. No, just all we know, we're calling EF1. We know that these angles are those measures. What is anything else? Any other side length, any other angle measure that we might be able to figure out then? Does that make sense? Okay? So, anything on this diagram, can we figure out any angle measure or any side length? So let's get to making conjectures. Let's get to work.
So I got a question. So what made you want to learn this? I want to do mine, but I want to look at the girls from work.
No, we're on page 12.
It look good. I want to love mine, but I don't know what it's going to look like.
Hold on. No, yeah, no protractors, no rulers. You're just trying to make a conjecture based on what we know. Great question, but I'm just asking you to make a prediction based on what we know. Let's get our conjectures on the paper, not writing on the desk. Let's write on the paper. So come up with some conjectures. Is there anything you might think to be true? Okay, what about the lines? Remember, we're just looking at this figure. Is there anything that we can figure out about this figure based on the information given? Do what? Yeah, it does look like a triangle, but like, so what does that tell us? Could you figure out what the length of AD is if we have a triangle there? Right, we already knew that. Let me ask you this: what do you know about AK? So look at that auxiliary line AK. Do you know anything about it? It doesn't remind you of any of the other lengths on that figure? It's not. If you're only looking at one line, it can't be a triangle. Any conjectures?
Get out. Oh, wait a minute. What?
Thank you. I'm going to just bring it back together for just a little bit to see what kind of conjectures we have going on. I'm going to let you go back to work because I just thought about it as like 10 minutes is a long time if we haven't even talked about any of these. Okay, so respectfully share out, right? So if someone else starts, wait till they're done sharing their idea. What is a conjecture that we might make from this? Maddie?
From AH to, like from AH.
So you're looking here?
And then H to K. And then K to A. It looks like a triangle.
Okay. Does that look like a right triangle? Okay. So notice I'm just asking, does that look like a right triangle? Yes, maybe. Okay. How could we check to see if it is in fact a right triangle?
Check the length.
Not check the lengths. See if there's a 90-degree angle. So you could you use a protractor to measure that angle?
Yeah.
Pick up a protractor really quickly. Check to see, does that create a 90-degree angle, right? So there's a claim, there's a conjecture. Use that protractor to check.
I need you engaging in this conversation. You're not even trying to listen to other people's ideas.
Tomorrow, when you were gone yesterday when we did this, how do you feel about using protractors? Do you need help with it? Do you know how to use this? What do you need to do when you have a protractor? You see that little corner right there? They put that on the vertex. Then you make sure that one of the segments is on the exterior. And then you come around to get the right angle. Remember, you have to make sure that that is on the vertex. Hey guys, remember that she wasn't here yesterday when we did this. Look, you always, hey guys, remember, look, eyes up here. You remember this little center where the hole is?
Yes, sir.
If you have one of the solid pieces, there's a little T intersection there. That always needs to go on the what? What's that point called? The vertex. Remember, you need this on the vertex. Then you can measure it. What you probably need to do is take this. By the way, don't forget, there's an easy way to take this out of the book without ripping. I showed you all that yesterday. I'm going to take this out. See how it's just nice and smooth? But from there, you you want the vertex.
Technically.
You see how that vertex is right in the center there? And I'm going to make sure that one of the sides is on this 0. That 180 is the same as the 0 here. So I'm going to come around inside. What angle is that? Okay. Okay. So there's a conjecture that we're testing. Alright, so let's look at it. Was this angle a 90-degree angle? Yeah. So there's an easier way. There's an easier way to check that, and we're actually going to learn about it in 2 lessons or 3 lessons in this book. So I'm not going to go into it yet, but notice there was the conjecture, hey, I think this might be a 90-degree angle. We can measure it to check that. That was a conjecture. And so we have a right triangle there. Any other conjectures from any other groups? Emily?
That, I don't know how to say it, like F to A to K, and then,
Say that one more time. F to A.
oh wait, no, sorry, it's the 2 angles where the vertex is A and then the vertex is H, the angles might be equal, like if you're looking
So this angle and this angle?
No.
Oh, you're talking about, I think I know what you're talking about. So you're talking about this angle, right? Are you talking about this one?
No, the ones in the right triangle that aren't 90 degrees. So yeah, the one on the left and then on the
You're talking about this one and
I
this
think
one?
so, that they might be equal.
Okay. So why do you think that? Joe, you can knock, bro. Why did you knock? Okay, Joey, do you want to give me your test or not, buddy? Okay. Thank you, sir. Okay, so
Hey, Joey.
Emily, what's your reasoning for that?
Well, we already, that K was 90 degrees.
Yeah?
And then just kind of looking at it, I was trying to figure out if any of the other angles look similar, but those are the only 2 that look the closest.
Okay, so you just felt like those were close based on this being 90 degrees?
Yeah.
Maybe? Okay, so I want to point this out. Let's look at it. Okay, so there's this claim that these 2 angles might be the same. So, in order for these angles to be the same, does anyone know what needs to be true about these sides here? Not parallel, but they need to be congruent or the same length. So I want you to think about this. From here to here. This isn't 100, well, does anyone know how I could find that length? Let's say that. No? Nobody?
You can use your
You could, but there's a formula that I know you covered in middle school. You say again tomorrow? No. That's a good thought. I like it. Okay, how about this? Really quickly, what type of triangle is this right here?
Right.
That's a right triangle, isn't it? Right? Built on that square. Anybody know possibly the most famous mathematical theorem that's ever been created? Pythagorean theorem? What is the Pythagorean theorem? So, we're going to use this heavily throughout this year, so let's go ahead and look at this a little bit, right? When we talk about, why are you talking while I'm talking? Yeah, stop mumbling to yourself. Focus. If you're mumbling to yourself, you're not listening to me, and if you're mumbling to yourself, you're distracting the people around you. Okay, so what do we mean by A, B, and C?
Angle A.
Be careful about that. Pythagorean theorem is not about the angles, this is about the sides. Be aware of that. So, this is one leg, this is one leg, and this is which side of the triangle? Starts with an H. Hypotenuse. Notice, The reason why I say one leg is because every right triangle has two legs and a hypotenuse,
Which is the hypotenuse.
which is the longest side. More importantly, the hypotenuse is across from the what? Can't be across from a leg, you can be across from an angle. The hypotenuse is across from the 90-degree angle. The hypotenuse is across from the 90-degree angle. The bigger the angle, the longer the side. And if that's 90 degrees, what do both of these angles have to be? Not 90. They have to add up to 90, so they have to each be less. They don't have to be 45.
Less than 90.
They have to be less than 90. Remember, if that's 90 degrees right here,
For a 2
these other two have to be less than 90 because they add up to 90. And so when we talk about legs, we're talking about the sides connected to the right angle. The legs are the pieces that add to the right angle. Now, anybody have an idea what this leg right here is? Right, we can say it's A, but does anyone know the length of it? This right here?
1.
It's less than 90.
What did you say?
1.
Why 1?
Because you said that E to F was 1, and if it's a square, every length has to be the same.
Ah, notice how there's a claim in evidence there? E to F we made be 1, right? And if E to F is 1 and these are all squares, A to I has to be 1. Anybody know what this side of the triangle would then be? Oh, now we're getting somewhere. So I need to find that hypotenuse, right? So 1 squared plus 2 squared equals not 3 squared, c squared. I want to point this out. If you were to say 3 squared, what is 3 squared? But what is 1 squared? Plus 2 squared is that 9? So is 1 squared plus 2 squared equal to 3 squared? Nope.
You gotta do 1 plus 4 and then take the square.
Okay. 5 is equal to c squared, but I don't want c squared, I just want c, so I need to take a square root. So the square root of 5 is equal to c. Now remember, Emily's conjecture was that these angles are the same. So we said that these legs here need to be the same. Find the length of K to H using this triangle here. Find the length of KH using that triangle there. So find the length of KH using the other triangle. You know the word. Oh, I was like, it's the wrong page. I got you now. Dude, you didn't write down any of the work that we just did. And Jaden, you didn't even write a single thing down. How well do you think it's going to work out for you in my class? You were capable.
Yeah.
But you're doing nothing. You know how much doing nothing? Dude, you're tired every day. Go to sleep earlier. Not me. Go to sleep earlier if you're that tired. I'll reach out to your parents if I need to. Figure out how we can get you to sleep earlier so you can learn better.
I tried to.
Joey, you cannot be sleeping in class. We cannot be sleeping in this class. Well, you take care of yourself. Have you found what the length to KH is? Did you do it? That's length is 1, that length is 2. So can you use the Pythagorean theorem to find that length KH? Have you figured out the length of KH yet? No. You're ignoring, excuse me, stop arguing and listening, and start listening. I explicitly told you to use this triangle to find that length. Because what kind of triangle is this? It ain't funny. It's not. Then why didn't you ask a question when we did stuff over here?
No idea.
Stop throwing blame on other people. I need you to focus. The whole thing was that this is a right angle because we have a square, right? So this is a right triangle. And what theorem? Hey, stop, dude. Stop.
Mind your own business. How about that?
Joey. No, sir. Step outside. Ain't funny. Leave him alone. Stop. If that's a right angle, or that, because this is a right angle, we have a right triangle. Because we have a right triangle, we were able to use what theorem? Can you use the Pythagorean theorem there? Yes, ma'am. Because we didn't know what the length was. Did you know how long this was? So we couldn't put anything there. We knew that that was 1, we knew that was 2, which is why we said 1 squared plus 2 squared, but we were trying to find that length. So we had to use a variable. Who?
Period. Judson Hall.
He's in my, first block?
Yes.
I got you. You can substitute those numbers in to find the third one, right? That's an equation with only one variable that can solve it. We're about to go over this problem. So, hold on. Come on, hold on.
Jordan, stop messing with those children. Jordan.
I asked him, look, this was the exact words I said. I was like, it's a real hammer. He said some words.
I mean, it was good. I had like an 8 on the plate. I had that's right. I had it's she was like, you know, I had to but I don't think I would have passed out with the glove. I probably give her an 8 grade.
Okay, ladies and gentlemen, I'm a little frustrated because what were the explicit directions I gave you when I left the board and asked you to figure out what the length of KH is? I said to use what?
The protractor.
I never said the protractor. I said technically to use this what?
Triangle.
This triangle. I even highlighted that triangle. I specifically said to use that triangle to find the length of KH. Using what we just talked about. Hey, what did we just talk about with that previous triangle?
Pythagorean theorem.
The Pythagorean theorem, right? Because when I look at this triangle up here, what do I already know about it?
It has a right triangle.
It has a right angle.
It's the same angles. Or
Okay.
same way.
Maybe, but we haven't proven that. We'll talk about that in a second. But let's look right here.
K to L is 1,
K to L is 1.
and then L to H is 2,
L to H is 2.
which means it's going to be the same.
It probably should be the same, right? We can check it, right? If that's 1 and that's 2, it's probably the square root of 5,
Because 1 squared plus 2 squared is 5.
right? So A squared plus B squared equals C squared. Anaya, are you, not Anaya, yes, Anaya, are you paying attention and taking notes on this? Because you were just asking how to do this. pick up a pencil and take notes when I'm teaching. Like, guys, we struggle in my class not because that we're not intelligent enough, but because we don't do the things to be a student. And if you don't understand when I go over something, then ask a question. Literally, a part of your active collaboration is based on you asking questions, sharing ideas, and taking notes. Like, that's part of your active collaboration. Engage in that process. Remember, though, A and B are legs. Technically, right now, do I know what the hypotenuse is? No. And Maddie was asking about this earlier because I left the hypotenuse as a C. And that's because, do I know what the hypotenuse is? When you don't know something, you leave it as a variable. But it's the same process from here. What's 1 squared? 1. What's 2 squared?
4.
Equals C squared. 1 plus 4?
5.
And then to solve for C, I need to take a square root. So yep, C, so the square root cancels out the square, and the square root of 5 is equal to C. So what do y'all think about Emily's conjecture that these angles are congruent? Is that true?
It's a true one.
It's a true statement, because we know that these sides are what? Congruent. Does anyone remember the name of this type of right triangle? Hold on, Maddie, I'll answer your question in a second. When two legs are exactly the same length? Say again. Okay, adjacent just means next to. We'll talk about that in a second. Is it isosceles or is it scaling?
It's
You said scaling at first, didn't you?
I don't know.
You're just saying? Okay. It's isosceles. Remember, isosceles should make you think of isolate, meaning something is on its own. The hypotenuse is on its own, the other two are the same. Right? So isosceles, right triangles. Say again.
I was wondering, is that what isolation means? Like when they in jail and you can't go up?
Yes, you are all on your own.
That's cool.
Okay, so these are connections between things. Maddie, you had a question? What's your question?
I was asking why you had to cross out the.
I can't hear you. Speak up.
I was asking why you had to cross out the 2.
This 2 right here. So the whole point is that a square root and a square are inverses, and so they are canceling each other out. Because they're inverse operations, they are canceling each other out. Good question. All right. Any other conjectures that we developed when we were working our small groups? There's 2 things I will point out in a second, but until then, I heard you come up with a conjecture, Thomas. Oh, was it Jamie's conjecture? What was y'all's conjecture?
You said
AG plus AK are a relationship.
So AG, right here. We see AG right here. And I think you said AK. They're a what? They're a reflection. What do y'all think? AG, could I reflect it and it gets to AK? And I want to point this out. If I were to reflect across here, would it map perfectly on top of the other one? Like if I take this piece and I reflect it across this line, would that line segment end up right on top of this line segment? Why do you say no, Emily? Okay? So let's talk about this really briefly. Ezra, I need you to control it, bud. When you do a reflection, a point will go directly to the opposite side of that line of reflection. And it'll go the same distance. So you see that distance there? I'm going to go the same distance across to here.
I was looking at the green one.
Oh, no. Sorry. AG. So if I reflect that across, will it map to here?
Yes.
Do you know what these 2 line segments are if they map to each other? Starts with a C. Something we've used a lot already. They're congruent to each other. I want you to notice, right? So these are things we want to start to notice. Could I go through the Pythagorean theorem to show that they have the same lengths again? Yes. But if I notice that, hey, just a quick reflection takes it across, then I already know they're congruent. Does anybody see a transformation that could take this blue line here, or line segment here, to this orange line segment here to show that they are congruent?
Yeah.
Which one?
Oh, and then go back up.
No, I'm saying like, okay, remember, here's my transformations. Translations, reflections, and rotations. How could I show that this blue maps to this orange?
Rotate.
Could I rotate this?
Yes.
If I rotate this, will it map to that orange piece there? It'd be a 90-degree rotation. Hey Jerry, that's not what we do with that, my man. That's how you break stuff. Thank you, sir.
I also see like from AK, it would be the same distance, just diagonal.
Okay, and that's true as well. Yeah.
And then next from K to G would be a triangle.
So K to G would be another triangle. Okay, so this would not be a right triangle, but that would be an isosceles because it has two sides that are the same. And so what I want you to get out of this, we're going to pause here because I'll go ahead and tell you, there's a million things you could talk about here. You could talk about the fact that this 18 degrees here is actually the same as this angle up here. Right? That 18 and this one are the same. We'll get into that lesson later. They're called alternate interior angles. Yep. We can talk about, I don't know, there's literally just a million things. So that's one of the big ones though. And so there's a whole lot of things we can talk about here. But again, you have conjectures that we thought to be true, right? Emily was like, I believe that these two angles here are the same. And then we found evidence to formally prove that, right? Jamie and Thomas were talking about, hey, it looks like those are reflections. If you go through the definition of a reflection, you can show that each point would map to each other. So we found evidence to prove that. Mathematics at its core is a whole bunch of patterns and relationships. We do need to work on our language to describe these things. And I need you to understand, this is a brand new unit. Every single one of you has a great chance of being successful, but if you are not doing what you need to do, it's really hard to be successful in my class. Make sure that you are engaged in trying. So really quickly, we're going to do this review that's in the lesson before we go to the next lesson. So go to, I think it's 2 pages after where we currently are. It's page 16, M1-16. There's a review there. So Marlon, you awake, my man? Head up, bud. So I want you to take a few minutes, and I'll go ahead and tell you, I don't know everything that you do and don't know already. So I want you to answer these questions, numbers 1 and 2, to the best of your ability. I will add on, okay, for number 1 here, identify 2 pairs of adjacent angles. So, answer the questions as are, but also with number 1, identify 2 pairs of adjacent angles. Let's get to work actively collaborating with each other to complete those questions. Page 16. Yep. Page 16. Answer those questions. Say again. Yes. Yeah, because you're getting tonsils out, right? Yeah. So we will definitely finish 2. We may get to 3. Say again. Yes. Do we see any vertical angles there? We haven't written anything. Say again. Do you all agree angle A is vertical to angle C? Say again, Maddie. gotta do what we can though. Identify any other vertical angles and then get to those two pairs of adjacent angles. And move to number 2. There's more than 2 pairs of adjacent angles, is all I'm saying. But identify all the vertical angles. I need to pause it. I want to just point this out. Nathan, you're saying things, and you're saying things, but are y'all actually talking to each other? Because if y'all are talking at the same time, are you listening to each other's ideas? And Nathan started talking. So Anaya, let him talk. See if you agree with his ideas, or see if you want to push back on and have an actual discussion. You are a small group. Work with each other.
Well, he's right though.
What have y'all talked about? How are you using A twice? A, B are the vertical angles. You agree with that? Okay. So then move to your adjacent angles if you agree. Make sure you pay attention and see if you need to adjust any of your thinking. You were here yesterday when we talked about this. Thomas is adjacent. What does that mean? Next to. Why did you put it adjacent? A and C are right by each other? But like, so if you were to, right now, would you say that these calculators are adjacent to each other? Sharing a single point like that, would you say they're adjacent to each other? Okay, let me say this. So here's this versus this. Which one is adjacent? That one? When they're sharing a common side like this, is when they're adjacent to each other. They're vertical. Does that make sense? So why do you say corresponding angles 1 and 4 are corresponding? Okay, so why do you say angles 1 and 4 are corresponding?
Oh.
It's true. Thank you. Thank you. Thank you. Alright, let's talk about some of these, see where we are. Can I get somebody to give me, just share out what your group said are a pair of vertical angles. Raise your hand if you want to share. Joe. Okay, this is what we're about to talk about. But did you talk with your small group at all about this? Okay, Joey, every time when you ask a question, you always tell me you didn't even ask your small group, man. Ask your small group first. You can do it. Okay? Joey. No, sir.
This is why I shall not every time I'm trying to ask you a question, you say to ask the small group. I don't even know anybody.
Hey, Joey. You can introduce yourself and get to know them.
What's the point?
Because then you have a resource. We're not going to shout about this in class. We can talk about this after. So, okay. So, within, I need somebody, because I see small conversations going on across this room, but they're not part of this whole class. Say it again. B and D. Okay? So, does anybody want to add on to that or push back on that as being vertical angles? Anybody want to add on to or push back on B and D being vertical angles? Jamie's not sure. I can see it in her face. Why do you want to push back on that, Jamie? Okay. So I want y'all to notice, and Joey, this is a part of the whole class conversation I was planning, is explaining what vertical angles are. So, so Jamie wanted to push back. Originally, I think, Jamie, what did you say was vertical to B?
A.
You said B and A were vertical. So can I get a third party in here to explain who they think is correct and why?
So vertical?
For vertical, yeah. Which of those is correct?
Probably the one where it's across, because like vertical is up and down. So, and adjacent means next to, so I would think like A and C.
Okay, notice we're going back to that language. The language matters. When we say adjacent, we mean next to. And so when we say vertical, what was the term Emily used there?
Up and down.
Up and down, there's another word to use.
Across.
Across from. Vertical angles are across from each other. So when you see vertical, what we're looking for are angles that are across. Because notice, are B and D vertical? Like, are they up and down? No. A and C are up and down, and B and D are horizontal. But really, we want to notice what we're talking about for vertical angles are angles that are across from each other. Does that make sense, Mary Lee? Because that was something y'all were discussing too. Okay. So B and D would be vertical. They're across from each other. What else would be vertical? A and C would be vertical. So when we see vertical, we are thinking across from. And so when we're thinking adjacent, we're thinking next to, beside. So we've already answered number one. This is the answer for number one. The answer to the second part, does anybody have a pair of adjacent angles? Ooh, actually, I want to pause and I do want to point this out. Say again, Joey?
I don't see anywhere where it says adjacent angle.
Well, Joey, when I started the whole class conversation, I told you I wanted you to add that in, bud.
Wait, what?
Yes, Joey, it's on the board, and I told you when we started the small group conversations that I wanted you to add that in. You were getting angry because you were not following directions, man.
I didn't even know it was open.
Yep, because you weren't paying attention when I gave directions. Ezra, I need you to calm it down, sir. Yes, Nathan.
For the adjacents we put.
Oh, hold on 1 second. Sorry, I do want to get back to that. I realized I actually made a mistake. I want you to look at this notation again for our answers. Is there anything there that has indicated we're talking about angles?
Angle.
The same. Are you talking answer?
Cross each other.
When I look right here at my answers, is there anything that says those are angles? What do I need to include?
Justification.
Well, this would be a part of the justification, but how could I show that I'm talking about angle B?
Draw that little, what is that called?
It's literally an angle symbol.
Okay. I thought there was something.
Nope, that's it. It's that plain.
Is there a difference between that and a carrot?
Like this, that's a
Oh,
caret.
okay, carrot's that one.
Yeah,
Okay.
that indicates an exponent in math. Okay, so angle B is vertical to what?
Sorry, D.
D. But notice we don't want to just say D, we want to say angle D.
Angle D.
Okay? So notice we're talking about angles here. We need to indicate that with our symbols. Similarly, angle A is vertical to angle C. So make sure we're using that to clearly communicate. Otherwise, A, B, C, and D would just be variables, not including the fact that they're angles. Nathan, you wanted to share a pair of adjacent angles. What'd y'all come up with?
AC and BD.
I just wanted one.
Or AC.
AC?
I mean, no, AB.
AB? Anybody want to add on to or push back on that at all? Jamie?
Angle A is adjacent to angle B.
Remember how we just talked about that, Nathan, that we need to include those angles and make that as a statement, right? Angle A is adjacent to angle B. Does anyone want to push back or add on to that?
So adjacent angles are the ones that are right beside it.
Yep, when you are adjacent to something, you are next to it. That's literally what adjacent means. Next to.
I don't know.
Yep. Okay. And so please understand, like, vertical, adjacent, literally it's what they mean as words, okay? Any other pairs of adjacent angles that we identified in our groups? Raise your hand if you want to share. No other groups came up with anything. Ethan?
I said A and B.
Okay, so is angle A adjacent to angle D? Anybody want to push back on that, or do we agree? We agree? Right? Notice angle A is next to angle D, and it's next to angle B. What is an angle that B, or what is an angle that C is adjacent to? It's also adjacent to D and B, okay? Okay, questions about vertical versus adjacent? Alright, so let's talk about this next section, number 2. This one is harder for more students because there's more involved. But it's the same idea as what we saw before, that the words mean something. When I look at A, I'm looking for a corresponding angle. What do you think we mean by corresponding? Does anyone know what that might mean in general? Jamie?
Something in the same spot.
If things correspond, they're the same, right? Maybe in the same spot. So looking up here, can anyone identify an angle that is corresponding to angle 5? Angle what? Would angle 1 be in the corresponding spot? So would they be corresponding? Yes. So angle 1 and angle 5. Because it's right next to corresponding, I'm not going to rewrite that as corresponding, but angles 1 and 5, they correspond to each other. It's just another way to do an angle symbol. Yeah. It's what I've always done, and I'm trying to break myself of that because that's not what the book does. Yeah. Okay. Talking your, does anyone see any other corresponding angles? 2 and 6. Anybody want to add on to or push, or does anybody want to push back on that, or do we agree? Well, I'll let you do that in a second. So 2 and 6, no one's pushing back. We're all good?
4, 8.
Well, hold on. Peyton said that she wants to add 1. So angle 2 and angle 6. So Peyton, which one did you want to say? It's 4 and 8. This is why we wait. We respectfully ask. Okay? I'm not going to write the last one on here, but what's the last set of corresponding angles? 3 and 7. Okay? So they're in the corresponding spots. Okay, so the next part, you literally have to break it down piece by piece. Yes, Emily?
Can you go like 1 and 4, 2 and 3, 5 and 8, 6 and 7, or is it just?
Well, but I want you first. So do those look like they're in the same spot? So what we're doing is we're comparing this set of 4 to this set of 4.
Okay.
Does that make sense? So we're comparing those sets of 4. Notice, if you're looking at 1 and 4, does anyone know a term for 1 and 4? They're adjacent to each other, right?
Oh yeah.
1 and 3 would be vertical. So notice we have our groups of 4, and we're trying to compare those groups of 4 right now. So I'm glad you asked that question, because that's a good question for sure. Okay, alternate interior angles. You got to break it down. What does the word alternate mean, or alternating? They go back and forth, right?
And then interior means inside.
And interior means inside.
Exterior means outside.
And exterior means outside. So I want you to think about it. When I look at these sets of lines right here, I could be on the inside or on the outside, right?
Mm-hmm.
So when I have the 2 pairs of lines, I've got the interior angles and I've got the exterior angles.